Topic of this video and associated handout is using the NIST26 Tandem Demo with Spectra imported from vendor software. It's part of a full course on NIST26 with newly integrated deconvolution library searching for LC-MS-MS, and you can see the link to that course on my site. So recommended, evaluate the demo as delivered. This provides the easiest introduction to its processing and search capabilities without demo software vendor interface changes. It's a fully functional software package for NIST26, ready to use examples including data files in greater than 500,000 MSMS spectra, integrated processing for deconvolution and library searching. Vendor Spectrum Import is not incorporated in the demo, but it is fully incorporated in the purchase version of NIST 26. Personally, I use integrated and vendor import when I'm processing data, so having the vendor import is a nice complementary technique for the software. Optional configuration for vendor to NIST tandem searching. Compatible vendor software can send Spectra to the NIST library search can often be very useful. However, the demo is not configured for this workflow as delivered. Changes may be required for folder names, file names, NIST executable names, etc. But several steps, but they're really not very difficult. This demonstrates in the video how to identify the paths and names expected by the vendor software, make the necessary configuration changes, etc. And at the end, after I've set up the software or shown you how, I will compare the integrated versus the vendor import approaches using the demo software that has been modified. This handout provides a practical example of configuring the NIST26 Tandem Demo to accept accurate mass LC-MS spectra sent from the Agilent Mass Hunter software. The general configuration principles may also apply to other compatible vendor software. Normally, in most of my videos and associated handouts, it's been mainly video, but you'll really need to use this handout to install the software and step through these steps. So I will not go through this outline. This is just to give you an idea of the things that you will need to do to make the modification. The things that I show you in the video will be comparing the integrated approach versus the vendor sent Spectra to the NIST search, and a couple of how to modify some of the files just to give you an idea of what approaches needed to be used to modify the software. I just want to show you a couple of the basic things I changed to give you an idea of how I manipulated the different files that need to be modified. The first thing I needed to do was install the NIST software, which I did from their website, and I give a link in there to how to do that. It's a little strange when you download it, you bring the zip file in, but you don't really unzip it, you just double left click on it, and it's really an installation piece of software. It installs the software. But after you do that, you'll go find the programs. You'll see the program group here. This would be the one that has the tandem here. So you can see everything looks good, but we'll need to change those names because they're not compatible with the vendor import port. So we have to go back out to the file directory, C drive, find out where it's loaded, NIST-DT. It had a different name. It had some hyphens in it, and I had to change it to NIST-DT. That's a standard type format, 6 characters, or which most of them had. So I changed that. When I changed that, I also had to go in and change the executable. When you change executables, you might want to be a little careful and save them as a backup before you actually save them. So I had to turn, this was a hyphenated file name, and again, it wasn't compatible with the vendor import. And you couldn't just make it NIST MS. It had to have the $ in front of it. So I saved that as an old version first, and then I just modified the name and saved it as NIST MS $.exe. Of course, when you change things like that, if you go to it now, it won't point to it in the program file. So I put an icon on my desktop. That's the easiest way in my mind. There's lots of different ways you could do it. But to do that, I had to right click. I had to say show more options. I had to go to send to, and I sent it to the desktop to create a shortcut. You can send it other places. You can put it on the taskbar. You can correct the program group if you wanted to, but for my needs, that's what I did, and I found that the easiest thing to do. All right, so the next thing, one of the major things that you have to be a little careful about, we're going to go into the Windows folder, and so you're at the Windows level. There's some protection on this site to protect people from causing problems with the file structure, but we'll have to make a small change here. It's not very large. So we're at the Windows, and we have to go find the win.ini right here. And I saved that. You can see I changed the old or temp. I just saved it in case I have problems. And this, the other thing you need to do is go up to the top, and you need to go to View, and you need to say Show file name extensions. You need to know what these extensions are. They can't be turned into text. This is actually a configuration file, and if you did it in the notepad, which we will, you might inadvertently save it as a text file, and then it wouldn't work. It has to be a configuration. So I'm showing the extensions here. You can right-click on these and open them with Notepad, and they're ASCII files that you can read. And the main thing you have to change here, before it was pointing to NIST EI demo, something with hyphens, and that just didn't work at all with the vendor software. So I changed both of these and saved it. But sometimes when you say file save, it won't let you save it to this Windows directory. That's on how you're set up. You definitely have to be the administrator for most of this, but sometimes you're not have enough privileges to save to this file, so you can just save into another place. And after you save it there, I was saving it in. I keep most of my things that we'll get rid of sooner or later. I'll keep them in the download folder. So I saved it into the download here. Here you can see where I saved it, and I'll copy that, and then I'll go back to the Windows directory. So go back to it, Windows, and all you have to do is right click and paste, or however you do your paste in, and it'll ask you, do you really want to do this? And it'll say it is a file that maybe you couldn't, but so you've got a backup of it, so just go ahead and say do it. So depending on what your administrative rights are, you might have to do this a little differently than I did, but that's the basic things there. So that's one INI file. We'll look at another INI file also. We'll go to C drive, and we'll go to NIST DT, and we'll go to, I'm going to find NIST ms.ini. Search for it. Again, this is an INI file, so you need to make sure you don't change that to text, and right click and go to Open with Notepad. You'll notice right here, the first time you open the NIST search program after you've downloaded, it'll ask you to point to where the libraries are. And you might have them somewhere else and you could use it, but if you're starting from scratch, I would put them in the NIST DT folder, so all your libraries are there. But at a later time, if you change your mind for one reason or another, you could edit this file and just change this library directory. Again, it's not a bad idea to make a copy of it, so if you have problems with it, you can go back to the original. I will show you how to install. There's also on the website, my website, there are 500,000 Spectra in 3 different libraries with 150,000 structures, and you need to download those and put them in the directory that's appropriate. And the appropriate directory is NIST-DT. You put them at high level. There's only one library present right now, and it's called Demo, I think. Demo.lib, and this is the one that comes with it. It has some files that you can process with it, and I think it's got 830 Spectra, but you can see it's a library directory by clicking on it. It's got all the indices. So you will need to put those 3 libraries I gave you at the same level here in the NIST-DT folder so you can use it for your work. So that's pretty much everything. That's all you have to mind. It's really not that many changes. I did an EI demo type program using with vendor software, and it's more there than it is here. This one's relatively simple to do. If you just pay attention and don't destroy something, just always save it, and you can always go back if you're having problems. Just keep a copy before you modify it. Now I want to show you how to set up all the configuration settings that you'll need. So we'll go to the chromatogram. This is the window that does the deconvolution library searching all in one step, and you get the best hit only displayed. Well, of course, in the live search over here, you get all the hits, like for however many. In this case, there were 35 Spectra in the hit list. You see them all. Here, you only get the best hit, which is a good place to start, especially in MSMS. That's often what you need to do. So let me show you how to set up the settings here. One thing is I like to have the structure here when there's a structure. Find one that has a structure, and right click on it on the window and say Properties and say Structure on Plot. It just makes it easier to review things. So that's the main setting in the open window. We need to come up and say File, analyze. We're not going to analyze it now. I'm just going to do the settings. You pick the ion polarity mode, positive. The tolerance is almost always for most works 20 parts per million for the precursor and 40 for the product. So that's good already because I've been in here, but it might not be that way when you get it right out of the box. The libraries, I told you we had the demo library. It had around, I think, 830 things in it, but these other ones, the Mona and these other three are the ones that I have on my website that you should download because they'll really help you evaluate the software. Total, we've got 52,000 spectra, no, 522,137 spectra in 4 libraries. So that'll give you a good set of libraries to do the demonstration on. The only problem is some of them don't have structures. There's 150,000 structures, but 500,000 spectra. I'll show you something about that later to maybe help you out there. So this is set up now. You can change the windows, anything you want to do. It's actually running the task now. I didn't really mean to run it. But it did it. To run this analysis, it did 135 components and it searched them in 10 seconds. So it's really, really fast. If you did one manually, you'd be lucky to import it from the vendor software and get it over to the search and do it in 10 seconds for one component. Here we did 135. So it found everything on the list and reported it at the bottom. So that's pretty much set up now. So let's go to the lib search window and set up the parameters there. Make sure this best matching only is not on for starters. We'll talk about that in a minute, but make sure it's off. And it's kind of hard to tell. You'll see if you look at the top, when you turn it on, it gets rid of duplicates. So the number up here will fall off. So you can tell when it's opened or closed. And also don't turn this on either. There's some don'ts there. The other thing is at the bottom, it shows at the bottom right, type of search, displayed MSMS, all that's right. We need to go up here where it says library search options. And we go in, we want to do an identity MSMS, which limits it by only things that have the precursor that's matching up within the window you told. And that's the way that the chromatogram window does. So if you want to compare apples versus apples, then you want to do it the same way. So we'll do it this way. There's lots of other different searches you can do, but we're going to do an identity with MSMS in Spectrum. It'll be imported over from the library list with the precursor you'll see up here. The top right is in the Spectrum, so you could add it manually if it wasn't there, but these will all have it in the Spectrum. MSMS, the tolerances will be the same as we used in the chromatogram tab. The libraries will be the same as we used in the chromatogram tab. The only thing different here, when you're doing a Spectrum search, you can pick your libraries that you do the structure search differently than you pick the Spectrum, but usually in most of my cases they're the same. But you can see there's only 151,000 here for greater than 522,000 spectra, so not everything will have a structure. So all of those settings are okay. We'll put automation on. That's good. I've got everything we want. One more thing, I like to display the structure down here, so I'll right click here and go to properties and say structure on plot and say OK. The other thing that we need to do up here is the options, the spectrum import options. We want to do accurate mass. Since we're bringing in accurate mass data, we want 4 significant figures all the way down here on the tandem spectrum accuracy. Don't touch this, the percentage of maximum. It'd be nice sometimes to filter out a little bit of electronic or chemical noise, maybe. But if you do that, it really causes problems. And I won't go into all the problems, but just don't use it. In the actual handout, it tells you why, if you're curious. So I think we've got everything. You can also change the window styles, move things around. On the top is the unknown. Here's a head to tail plot. You can do side by side. There's a lot of options here. Most ones you can right click on them and go properties and find out things. You can also go to the top, I think, and hit, is it F1? F1, it came up on the other screen. On any screen you're in, if you hit F1, it gives you information. And they've done a pretty good job of putting in user information that you might find useful here. So if you're on a window and you push F1, it brings up information. Then there's more help up here also. So take a look at the help. It's very, very useful. We've pretty much got everything we want now. So what we need to do now, we don't want to have to do this every time. So we come up to File, Save Configuration. We'll call this maybe DE Default under Demo under Tandem and save it. And now if you change something or you get confused, you change some of the options while you're processing, you want to get back to your default, just come up here. You can see it already has it here. You could just click on that. But if it wasn't there, you could look at the list within the file and bring it back so you could restore your settings. So it's very good. Always think about saving your configuration. You might have different configurations doing different things. So it's nice to have different ones for different needs. So be sure to take advantage of that. It's a real nice option within the NIST software. So one last thing, I just want to show you the integrated approach versus the vendor approach. And we'll just go back to the chromatograms. I've already done this once, but I'll do it one more time for emphasis. So we'll go up to Analyze MSMS Input File, and we'll go select our file. And I'm going to use this forensic tox mix, and I gave you that on my website if you want to use it for comparison. They have some own demo files, but I like mine because I'm more familiar with them. So we'll positive, library's already selected, the tolerance is right, so everything's good. So we'll just say OK. You'll notice it's running up here, running task right here. You can run it in the background and do other things if you want to, but it took around 10 seconds. What you'll see at the top is we had 135 things searched. It's actually more than that because you usually display best hits here. So you do the best hits because the best hit usually is the one that it is, the way they process the data. So it's better to have it on best hits. But to get to that point, they had to do 533 library searches of the separate spectra in the list below to get the results. And so that's fast, 10 seconds, 533 searches. But we need to turn best hits back on. And there's a discussion on my website about why they do it that way, but keep best hits on. You can keep background about 90%. That's all very good. So we're good here. What I'd like to see is just the major ones usually. So all of these are sortable and stretchable, whatever you want to do. If you click on something, it resorts it by abundance and puts the abundance at the top that's 100%. You can see here, abundance is on the left, total ion current for the MS1 is on the right. So I've got the ones here. And what I'm going to do, listen carefully. I'm going to left click here to select the first one. I'm going to hold the shift key on my keyboard, on my keypad, and I'm going to come down to, let's say 1.8%, and then say right click. And so that selected a group of things, and I can say show selected. Now I got rid of a lot of the small things. If I want to get rid of some more, I could do it again, maybe do 99. Let's do down to 3% this time. And I've selected it again with the selecting the first one with the mouse click, left mouse click, holding the shift and going to the end and click the last one, and you get everything in between and say show selected. And nothing really goes away when you do that because you can just go back and say, if you want to, you can say show all, and you go back to where you were. So you never really lose anything after it's been searched. This is just a way of filtering things out you don't want to see. So if we go to the top, you can see that's trazodone there. Find what the structure, because a lot of these don't have structure. Here's one that's got a structure. It's diazepam. Let's say you didn't know what trazodone was. You can select it with the left, or you could select it with the dot. But I'm going to select it with the left on the bottom. I'll right click and say library search, and it sends it over to the lib search thing. Now, instead of just giving the best hit, it gives you all the hits. And so we got a bunch of trazodones, don't we? So I'll just pick the first one. I picked the first one with my left click on the keyboard, and now I'm using the up and down arrows. I'm going with the down to get to the second one, and there you can see the structure of trazodone. So this is handy if you don't know what trazodone is. I wouldn't know what it is. Just to go find one that does have the structure for showing what it is. But if you wanted to see the best thing past trazodone, you have to step through a lot with your keyboard, and that gets a little boring after a while. So come back to the top, the best hit, go up here where it says best matching only. And now you'll see the next one down is trazodone hydrochloride, which would look very similar to the other. The next one would be something else, maybe like it. So you get to see other things that are like it here by getting rid. But see, the hit fell way off. We got 850 here for the trazodone, but these hits fall off precipitously. So that's definitely the best hit. But remember to turn that off. I like to have it on initially to show them all, rather off in a sense. Don't show just the best matching. I like to see them all. And you can also filter here, but don't filter there in general. If you do, be sure to save them back because it can be confusing and it might, you don't necessarily get the useful results that you need. So that's pretty much processing something within the chromatogram tab with the options to send it to the lib search. The chromatogram, again, gives you the best hit. So one hit for every entry, which in most cases with the NIST search software doing this precursor limited search is probably the right things in most cases. But if you have doubts or you don't know what the structure is, just right click on, like I showed you, do a library search, and now you do the lib search window, and you'll get all the different hits. Here we got 34 spectra. Again, you can see again when you turn this best matching only, it dropped it to 8. So that's a way to tell if it's on or off. It's difficult to see if that's actually on or off. But when it's off, you'll get the most number of spectra. So that's the chromatogram. Now we'll go in and do one where we transfer something from the Mass Hunter software and see how that works. So now I've opened up Mass Hunter to send something to the NIST search. I need to talk about file type. So we'll open a data file here. Here you'll have this on my website, Forensic Cox Test Mix. And it's you have to read the whole name to make sure you have the right one, but this is actually an automated one where the transitions itself as it goes along acquiring the data. But you'll notice it's in .d format. So you need to process within the Agilent by selecting a .d file. When you select within chromatogram, you'll notice it only selects MZML files. It's almost like a standard shared format between manufacturers, and you use a converter called Proteo Wizard and MS Convert to convert, let's say, this .d to an MZML. But you'd have to do the conversion. So you have to open a .d here to process in the native format. But when you go to the chromatogram that's integrated within the NIST search, you can only use MZML. So remember that. That's very important. So I'll open this to open the file. So it's already open, it told me. So I want to expand here. I'll do the same peek I did over there. So I'm just expanding. Here, I told you you can't filter out things. You can average across the peak if you want to in Mass Hunter. But when you do that, it loses the precursor information in some cases. It loses the energy, and also it gives more, it's more electronic noise. It's not really chemical noise, but it's electronic. So I tend to go to the top of the peak and double left click on it. On the top here, you can see the MS1 spectrum at that point, and the bottom's MS2. So I have to make sure I have MS2 selected. So I left clicked on it. Now I right click and say search using NIST MS program, and left click on that. And it went to the library, and we have it set up for automated insertion. So it essentially did the search. And here's our unknown on the top. You can see it brought in the energy. I'm looking up here in the right corner. It's from a QTOF. It's got the precursor ion. It's got all the mass to charge intensities. And so you can see here's the precursor. Still some of it left. It didn't break all of it up. And this is the hit that I'm on. So here's the spec list where it imported something. These are other ones that I've imported before. So I've got the one that I've imported, and in the bottom are the results. So you can see it's similar when you send it to LibSearch from Chromatogram, and we've got all the hits. You can step through them and look at them by using the arrows on your keyboard. And so I'm just clicking down, and you compare the middle, which is the head to tail. And the top is the unknown, bottom's the known, and you can step through them pretty quickly. But again, as I told you before, we're getting a lot of trazodone hits, aren't we here? There's 35 spectra in the list, but most of them are trazodone. So we can stretch this if we want to. Some good hits for all of them. So if we wanted to get down to the next thing that wasn't trazodone, remember, go up to the top, click on best matching only, and now you'll see the other ones. But again, see the hits are falling way off, down to 0 from 841. So really nothing else of interest. So remember, it's best to keep that off initially. So you can see that probably took, I don't know, 10 seconds by the time I got it over there and clicked on everything, maybe 5 seconds. That did one spectrum. And the other one, remember, we did, how many was it? We did, if you turn best hits off, we actually searched, I think it was 500 and something at one time, and it only took 10 seconds. So you can see it's much more efficient to do the chromatogram search, but it's still, a lot of times you want to look at things manually. So I always like to have the ability to do it manually by vendor import and also by this new, very exciting approach that NIST has for doing deconvolution and library searching all in one window. It really is a good piece of software. So give it a try with the demo software and the libraries, and it's very inexpensive. The MSMS library is really, in my opinion, for what it is really just dirt cheap. It's a great value. So if you like it, consider buying the 26 software, which will have the vendor software already set up pretty much, and will have a huge number. I think it's a huge number of Spectra, so much greater than we have here, and also, more importantly, much higher quality MSMS Spectra. So give it all a try, take a look. Good day.